This is a review of future Earth scenarios and an examination of what can happen if we don't start reducing greenhouse gas emissions quickly. By now, you should have watched the 2 videos posted under the Hothouse Earth topic on Moodle. If you haven't, I suggest you go back and watch those videos before watching this one. We have learned already about different RCPs and how they represent different futures for Earth. Remember RCP 8.5? That's the business as usual model where we continue to emit greenhouse gases at the same accelerating rate that we've been doing for the past few years. Well, this and the next slide show where we are probably headed if we keep going on that pathway. What you see here is a graph where the axes run through the middle of the graph instead of the sides. The y-axis, or vertical axis, shows temperature change in degrees Celsius, and the x-axis, or horizontal axis, shows sea level relative to pre-industrial levels. As you should remember from previous classes, as average global temperatures rise, sea level also rises because of the melting of polar ice and glacial ice in tall mountains. Also, water expands as it warms. Now the curves on the graph illustrate how Earth varies in temperature and sea level over geologic time. Remember the ice ages, the long periods of extreme coldness with brief interruptions of warmer temperatures that Earth cycled through during the Pleistocene? The ice ages are represented in the lower left portion of the graph. The arrow shows Earth when it is leaving a warm interglacial period and entering another ice age. Climate is cooling and sea levels are dropping. This arrow is where Earth would be during the peak of an ice age, when temperatures were much colder than today. Sea levels were also very low because so much water was trapped in the form of ice. The difference in average temperature between today's climate and the peak of an ice age is just a few degrees, which illustrates how sensitive the planet is to cooling and warming. Now this arrow illustrates where Earth pulled out of the last ice age due to changes in Earth's orbit around the Sun. From here, Earth enters the Holocene, that period of 10,000 years up to now that have been warm and stable. But now, thanks to greenhouse gas emissions from the burning of fossil fuels and deforestation, Earth is here. We have begun moving in the direction of a climate that Earth has seen many times in the past, one that is called Hothouse Earth. This is the RCP 8.5 business as usual scenario. If we get stuck in this cycle, Earth will warm considerably over the next century and beyond, and sea levels will rise dramatically. Recall that the last time carbon dioxide levels were as high as they are now, Earth was 4 to 7 degrees Fahrenheit warmer than during the pre-industrial age, and sea level has been estimated to be 72 to 82 feet higher than now. Instead, we need to be here, bending the climate back to something like we had during the past 10,000 years of the Holocene. This is a 3-dimensional visualization of some of the same information we just saw. The x-axis, which crosses left and right, represents how cold or hot the Earth is. The vertical axis represents climate stability. The higher on the graph towards the top of the screen, the more stable Earth's climate is. The lower on the graph, the more unstable. There is a third axis here, one that travels toward and away from our perspective. It represents time, with the future and current time being close to us and distant times farther away. Check out the distant Earth ball, the one that is closest to the top of the slide. Note the red arrow indicating it. That represents Earth during the Holocene, a time when Earth was warm, not cold like the ice ages, and not hot like a Hothouse Earth situation. Earth was also stable in the Holocene, resting that little notch of the graph. But as we moved forward through time, and we started deforestation and then industrialization, we added greenhouse gases to the atmosphere. Today's situation is represented by that middle Earth, indicated by the red arrow. From here we have 2 directions we can go. If we keep on going like we're doing now, the RCP 8.5 business as usual pathway, then we'll likely hit what's known as a tipping point, indicated by this arrow. This is a planetary threshold where we plunge irreversibly into a hothouse Earth situation. Climate scientists estimate that we will be very near this threshold when we warm the atmosphere by about 2 degrees Celsius above pre-industrial levels. We are already at 1.1 degrees Celsius now in the year 2020. What climate scientists and others in the know are recommending is that we quickly and dramatically reduce greenhouse gas emissions and steer Earth's climate back to the stabilized Earth climate of the Holocene. That is represented by the Earth that is closest to us on the graph, or in the bottom center of the screen. All of this illustrates why many scientists, myself included, and others, are very concerned about climate change. A lot is at stake, and what happens in the next decade will determine the living conditions for humanity for centuries to come.